I hope everyone's doing well. I am Mr. Ish. Thank you for joining me for this video. At the high school level, we're looking here at the organic oxidation and reduction cycle, the manner and type of steps which are involved in oxidizing and reducing organic compounds. And it's not hard by any means, starting here with acetic acid, vinegar, CH3C double bond OH. If you wanted to reduce this, you can. Lithium aluminum hydride will get rid of this carboxylic group, which is COOH, carboxylic group, and it will reduce it. How do you know that this compound is oxidized? Simply by the presence of the oxygens. The more oxygens in an organic compound, the more oxidized it is. The fewer oxygens and the more hydrogens, the more reduced it is. Lithium aluminum hydride converts this carboxylic group into a alcohol, and it would be CH3CH2OH. Your carboxylic group has been converted into an alcohol, and it's a reduction step, and you've noticed an oxygen has been lost. Here we had one hydrogen, now we've added two more. We've reduced it. What can we do over here? We can get rid of that hydroxyl group through an elimination reaction. By eliminating the hydroxyl group, we can using sulfuric acid and heat. When you do it, you have an elimination reaction and you convert hydroxyl group into a carbocation, which will then quickly go into this procedure right here, CH2 double bond CH2. We've eliminated it and created a double bond over here, and alkene and ethene has been created. And you can say right here ethene, ETHENE. What we can do over here is reduce it even further. And how would we do that? By a hydrogen and palladium catalyst, H2PD, and we'll convert it into ethane, CH3, and now it's in its most reduced form. Vinegar or acetic acid has been fully reduced. No oxygens and a larger number of hydrogens are seen in this end result. Now we can start oxidizing this again, and we can. If I were to hit this with bromine in the presence, a diatomic bromine in the presence of UV radiation, I'll do a free radical reaction. I'll bring here a bromine, a ethyl bromine, CH3CH2Br ethyl bromide. And what I can do is an SN2 reaction, a nucleophilic substitution reaction, SN2, and I can get rid of this bromine and bring in an alcohol. I have now generated ethanol, ethyl alcohol, CH3CH2OH. Now we're oxidizing it again. We're removing hydrogens and bringing in oxygen, and we can oxidize it back to our starting compound by using potassium permanganate. It will fully oxidize this alcohol into this carboxyl group, and we're back to where we are. So this right here is your cycle. Starting here from a carboxylic, we can do lithium aluminum hydride, convert it into an alcohol, eliminate it, convert it into an alkene, fully reduce it by means of hydrogen and a catalyst into an alkane. Then we can start working it back towards an oxidation bunch of steps. Bromine, ionizing radiation, SN2 reaction, hydroxyl group, and then oxidize the alcohol into a carboxyl group, and the cycle comes to a complete. So this right here is something you should know. Thank you for watching.